Okay. Good evening. It's October 2023. My subject matter for this evening will be this is the most interesting part of trigonometry. Because without knowing this, you will not pass trigonometry. This is the foundation of trigonometry, the basic definition of trigonometric functions. We are done with the study of angles, okay? We know how to measure angles in degrees, radians, and other units, right? For tonight, we will be studying the concept of the so-called the different trigonometric function. Without knowing this trigonometric function, you will not pass trigonometry. Okay, let's proceed. The subject matter for tonight will be trigonometry, lesson number 7. And this is the title of the topic will be trigonometric functions of acute angle. The formulas that we will be bringing out here will be applicable to only angles less than 90 degrees. Okay? Angle A and angle B should be less than 90 degrees. If it's equal to 90 degrees, that will be a different story. It will not work. Okay, so the application of the trigonometric function will only apply for acute angles. Okay, let's try to define what is an acute angle. Acute angle, the simplest definition is an angle that's the value is less than 90 degrees. Less than 90 degrees. Less than 90 degrees. This is a 90 degree, okay? So considering this right triangle, this angle here is less than 90 degrees and this is 90 degrees. So for the definitions here, it will only apply to this angle here and to this angle and not to this angle. Okay? It will only be to this angle here or to this angle. Okay? Right triangle. All the formulas that we will be bringing out for tonight will only be applicable to this angle here and this angle. Okay, and it will not be applicable to angle C, the right angle. So it will only apply to angle A and angle B. Okay, because angle B and angle A is actually less than 90 degrees. Okay, let's try to bring out the different abbreviation functions under the study of trigonometry. Okay, you must have to memorize this by heart. Memorize this by heart. Without knowing this, you will not pass trigonometry. Sine, the abbreviation will be SIN. If you try to read this and you are under trigonometry, you will not read this as sin. You will read this as sine, because this is just the abbreviation and the complete wordings will be SINE, sine. Okay? For the cosine, the abbreviation will just be simply COS, but don't read this as cos maybe. If you try to read this under the study of trigonometry, it is understood that this is cosines. It is cosine. It is just abbreviated cos, COS. For tangent, the abbreviation is TEN. Okay? So if you try to read this under the study of trigonometry, don't read this as just simply tan. Okay? It should be tangent. Tangent. Next one. Cotangent. It is a tangent with an initial letters over here, CO, cotangent. And the abbreviation of this will be COT. If you try to read this, it should read, not cut, right? It should be cotangent. Okay? Next one, secant. Secant is abbreviated SEC. Okay? But if you try to read this, it is not SEC. It should be secant. This is just the abbreviation, right? What's next? The last one. It's the secant with an added letter CO, like the cotangent, right? There is a CO here. For the secant, there's the cosecant, CO plus secant, or in total words, cosecant. And the abbreviation will be CSC. CSC. Okay? CSC. Okay, I will try to repeat the abbreviations. This is red sine, cosine, tangent, cotangent, secant, and cosecant. Memorize this by heart. Without knowing this, you will not pass trigonometry. Okay, to bring out this abbreviation of function here, this is actually related to a right triangle. Okay, it is related to this. So you should familiarize yourself in the so-called formulation of the concept of this one. This is always based on a right triangle. Okay, the inside angle here is a capital letter A, angle A. The inside angle here is capital letter B. The inside angle here, the right triangle, is capital letter C. And the sides are designated by small letters. This is A, B, and C. Okay, the designation is small letters for the sides, and for the angles, the inside angles, that is angle A, capital letter A, capital letter B, and capital letter C are actually angles. Small letters are A, B, and C. Okay? Oh, it's here. Capital ABC are the angles, the inside angles of the right triangle, and the small ABC are the sides. There are two variations on how to bring out, okay, the definition of the different trigonometric functions. It depends on what angle you are considering. Okay, that's why I place it here. With respect to angle A, where is angle A? With respect to angle A, this angle A, the opposite side of this is this one. Okay, and this angle B here, the opposite side is this small letter b. And the inside angle capital letter C, the opposite side is C, the hypotenuse. Right? So with respect to angle A, with respect to angle A, the big angle, A will be the opposite side, B will be the adjacent side, and C will be the hypotenuse. Or in short, A will be OS, meaning opposite side. B will be adjacent side, will just be simply ES. And C will be the hypotenuse. It is designated by capital letter H. Okay? That is with respect to angle A. Okay? But if we are considering angle B, that's a different story. For angle P, this A here will now be adjacent because it is adjacent to angle B. Okay, it is here. Adjacent. They are near each other. They are not opposite. Kaya, what they call this, considering angle B, this A here will be adjacent side, and this small letter b will be opposite side. It's opposite. Considering this angle. And considering angle A, angle B, this should be opposite side. So in the definition, it will be a different one. So with respect to angle B, A is the adjacent side, right? It's the opposite. And B will be the opposite side. And for C, it will still be the hypotenuse. It didn't change the location. So there's no problem with angle C. Okay? They are both the same for angle A and angle B. But for the opposite side and adjacent side, actually it's a different story. Because for angle A, okay, small letter A is opposite side, small letter B is adjacent side. Considering angle A, this is opposite side, this is adjacent side. Considering angle B, this is adjacent side, and this is opposite side. Okay, B is opposite side considering angle B. Okay, so at least you know what is opposite side and adjacent side. Adjacent side meaning it is near the angle considered. Okay, opposite meaning it's opposite side. This is angle A, this is its opposite. Considering angle B, its adjacent side is angle A, right? It is adjacent to it, and its opposite side is angle B. Okay, so at least you know what's the difference of an opposite side and adjacent side. So considering angle A, again, I will repeat it for the last time. Angle A, B will be its adjacent side and A will be its opposite side. And for angle B, its adjacent side is small letter A and its opposite side is small letter B. Okay? So the important thing here is at least you know what's adjacent side and opposite side. There's no problem with the hypotenuse. It will not change location. Right? Considering this angle, this should be adjacent side, this is opposite side. Considering angle B, this is adjacent side, this is opposite side. As simple as that one. Okay? Oh, let's try to bring out the basic foundation of the definition of trigonometric functions. This is very important. Many students, okay, don't know how to, I don't know why they can't remember this one. Principal trigonometric functions. These are the basic definitions, and for as long as we are living, these definitions will not change. Okay? So for a sine function, it will be opposite side over hypotenuse. Okay? And a cosine function will be adjacent over hypotenuse. And for a tangent, it should be opposite over adjacent. Okay? And for the next three, it's the reverse of this first three here. Cotangent will be the reverse of tangent. It will be adjacent over hypotenuse. Cotangent. Adjacent side over hypotenuse. Second, sorry for this one. Adjacent side over opposite side. This is opposite side. Okay? Because cotangent is the reverse of tangent. Okay? Sorry for this one. Cotangent function will be adjacent over opposite side. And second, it will be the reverse of cosine. It will be hypotenuse over adjacent side. And for cosecant, it will be hypotenuse over opposite side. Okay? These are the basic definitions, and this will not change. As long as you know the definition of a sine, cosine, and tangent, you will not get lost. Okay, it's like this. Considering this angle, if we try to take the sine of this, okay, it will be opposite over hypotenuse. Okay, opposite. I better use the paper so we consider the angle. If we try to take the sine of angle A, okay, from this definition, it should be opposite over hypotenuse. And if you try to take the cosine of this angle here, it should be its adjacent, okay, over hypotenuse. Okay, and if you try to take the tangent of angle A, it should be opposite over adjacent. Opposite over adjacent. Okay? And if you try to take the cotangent, it will be the reverse of tangent. It should be adjacent side over opposite side. Right? And for second, it will be hypotenuse over adjacent side. And for cosecant, it should be hypotenuse over opposite side. Okay? We apply this one considering this angle. It's just like a sine of angle A. Okay, we'll place a value now so you will not get lost. If we try to place angle A here, I'll place it here. Sine of angle A It's opposite over hypotenuse. It's considering angle A, the opposite side is actually A over C. Cosine of angle B, the adjacent side is B over C. And tangent of, this is angle A. We're just considering angle A. For the tangent of angle A will be opposite side over adjacent, that is A over B. Okay? This one actually emanates from this. This is just the basic definition. Sine of angle A is its opposite side over hypotenuse. A is actually opposite side, right? Over hypotenuse, C. And cosine of angle B is actually adjacent. Adjacent is B over C. And tangent is A over B. For the next two here, just take the reciprocal of this and you could actually derive for cotangent of A, secant of A, and cosecant of A. Okay, just take for the cotangent, just take the reverse of this, it will be B over A, right? And for secant, it will be hypotenuse over A, okay, over A. Over B, over B. And for the cosecant, it will be hypotenuse all over C. Okay? It is this. If you know these three here, you could actually compute for cotangent, secant, and cosecant by just taking the reciprocals. Because tangent is the reciprocal of cotangent, and sine is the reciprocal of cosecant, and cosine is the reciprocal of cosecant, or secant. This is hypotenuse, this should be C over B, right? It's the reverse of this. And for cosecant, it should be the reverse of this. It should be hypotenuse, this is all over A, all over A. Sine and cosecant are reciprocal. So if sine is A over C, cosecant will be C over A. If cosine of A is B over E, since they are reciprocal, secant will be C over B. And for tangent, if tangent is A over B, okay, cotangent will be B over A. This is the basic foundation of the definition of trigonometric functions under the study of trigonometry. Okay, these are the basic definitions, okay? The angle relations. Angle A plus angle B is equal to 90 degrees. I will try to illustrate in here. The sum of angle A plus angle B should be equal to 90 degrees. Okay? This symbol, it's just like an inclined L is actually the symbol for angle. So if I will try to write like that, this means angle. Okay? So if we try to read this, angle A plus angle B equal to 90 degrees. Okay? And for the side relations, we use the Pythagoras principle. The square of this plus the square of this equal to the square of the hypotenuse. So for the side relations, A square plus B square is equal to C square. It is this. And for the reciprocal functions, like what I did a while ago, so you will not get lost. The reciprocal functions are this one, because I brought out this reciprocal functions under my community post. Many had made some wrong, answers over there. So try to, remember this one, so you will not get lost on the so-called reciprocal functions under the study of trigonometry. The reciprocal functions are actually sine and cosecant, and cosine and secant, tangent and cotangent. Meaning to say, if you know the definition of sine, okay, just take the reciprocal of this and that will be cosecant. If you know the definition of cosine, to take for the secant, just take the reciprocal of this and that will now be secant. And for tangent, okay, to take the value of a cotangent function, just take the reciprocal of the tangent function and that will be the cotangent. An example of this, sine of angle A will be 1 over cosine of angle A, cosecant, by using this relation here. Cosine of angle A is 1 over secant of angle A because cosine and secant are reciprocals. Okay? And tangent of angle A will be 1 over cotangent of angle A. Okay, that's it guys for this topic. Try to memorize all these concepts by heart because without knowing this, okay, you'll got be a hard time at studying trigonometry. Okay, good evening from Los Angeles. Professor David J.